4, getting into triangles, and more specifically triangle congruences. So we got to get our base facts on our triangles down first before we can get into that stuff. So this section 1, we're going to fly through it pretty quick. A lot of this stuff is stuff you know from elementary school, and we're just going to expand on it a little bit. So first of all, remember we can classify triangles by angles or by the sides. Well, first by the angles. I got a triangle here, this left one. There's all acute angles in this triangle. If every angle is acute, we can call it an acute triangle. Pretty simple. And if every single angle in that acute triangle happens to be the same angle measure, right here, like that, if they're all the same, they'd all be 60. We'll get into that next section. But we call that equiangular. It's kind of like equal, right? Equal angles, equiangular. Looking at this next one, I have an obtuse angle right here. Well, if there's one obtuse angle in my triangle, we call it an obtuse triangle. Pretty simple again. And lastly, I have a right angle right here. So what do you think we call it? A right triangle. So there's our 3 types of triangles, naming by the angles, classifying by the angles. So let's use that once. It says classify the triangle as acute, equiangular, obtuse, or right. Well, if I take a look, I have 45, 31, and what is this total right here? 45 plus 59 gives me 104, which means that's an obtuse angle, which means my entire PQR triangle. Notice how we say triangle PQR. That's how we label triangles, especially when we get into our proofs. And I'll say that is obtuse, or an obtuse triangle, because I have one obtuse angle. Pretty simple. We can also classify by the sides. I think this first one, most of you remember, when all sides are congruent or all sides are equal, we call it equilateral. Equilateral. All sides are the same. Looking at the second one, now I have 2 sides the same. I got 2 sides that are the same, hence the 2 marks here. Okay, we call these the legs. So when I have 2 legs that are the same with a base on the bottom, so legs are the same, base is on the bottom, we call this isosceles. This is an isosceles triangle. And I always think of it, I'll get you that in a sec. And the last one, no sides. So no sides are the same here. No sides congruent. We call this scalene. The thing I usually remember the difference between isosceles and scalene, I look at the S's for sides. Here I have 2 S's for 2 sides congruent. Here there's only 1 S and a side congruent to itself, I guess. I don't know. So no sides are congruent. So that's why I think isosceles has the 2 S's. That's how I remember that it has 2 sides congruent. So let's use that information. If y is the midpoint of Vx, I'm going to stop right there. I'm going to figure out what that meant. Y is the midpoint. Well, that means that these 2 are congruent, and I know the whole thing is 8.4, so these 2 have to be the same. So I can take 8.4 divided by 2, which equals 4.2, so that means this guy's 4.2 and this guy's 4.2. I'm going to use that right away before anything else. And then it tells me that Wy is 3 units. So I'm going to go ahead and write that in. Wy, that's 3.0 units. I'll just put 3. Classify Vwy. Well, where's that at? Vwy. There's that triangle. As equilateral, isosceles, or scalene. Well, if I look at the 3 side lengths, 4.5, 3, and 4.2, they're all different. So which one has all different? Scalene. And this is explain your reasoning. Well, I just explained it by showing my side lengths, 4.5, 4.2, and 3. So we're done. Last thing, find the measure of the sides of isosceles triangle KLM with base KL. This is important here. We said the base is KL, which is right here. So this is the base side, which means the other 2 are congruent, right? Because those are the legs. Well, if those are congruent, I can set these two expressions equal to each other. So I got 4d minus 13 equals 12 minus d. And then we go through our algebra. So we add d to both sides to get the d to one side. I'm going to add my 13 to the right side. I like to do this all in one step. So I got 5d, that's gone, equals 25, and that's gone. And we can solve for d, divide by 5, so d equals 5. But I'm not done. I'll always go back and reread your directions. It says find the measures of the sides. So I'm going to state this. I'm going to say that KL equals, well, if d is 5, I can just plug it on in there, d plus 6. So 5 plus 6, which is 11. And then all I have to do is find one of them because they're the same. So LM and KM, they're equal. So I'm going to find LM. I'm going to plug 5 in for D right there. So 12 minus 5 is 7. And I know this is 7 because those are congruent. So there's my 3 answers. So always go back, reread the directions. Be careful. Just because you solve for D doesn't mean you got the answer they're looking for. And I don't have any units here, so 11, 7, and 7 is fine. Okay, pretty straightforward. Stuff that you learned in elementary school, and then we're just expanding on it using some algebra.